Hello students, welcome back to this lecture, one pair of linear equations in two variables. So in our previous lecture, we have started pair of linear equations in two variables. And there we have seen how to solve a pair of linear equations in two variables by using graphical method. Okay. So now here in this lecture, we'll discuss example 2, one graphical method of solutions of a pair of linear equations. Okay. So in this example, we have asked how to find whether the following pair of equations has no solutions, unique solutions, or infinitely many solutions by using graphical method. Okay. So here we have given this pair of linear equation 5x minus 8y plus 1 is equal to 0, and naming this equation number 1. Okay, and the second equation 3x minus 24 by 5y plus 3 by 5 is equal to 0, and naming this equation number 2. Okay, now we have to find whether this pair of linear equations in two variables has no solutions, unique solutions, or infinitely many solutions. Okay, so let us see how to solve this. So here first we multiplying equation number 2 by 5 by 3. Why we multiplied by 5 by 3 in equation 2? Because in equation 2 we have the coefficients in fractions. So for simplifying, here we multiplying equation 2 by 5 by 3, and we'll get 5x minus 8y plus 1, this is equal to 0. Okay, and this is the same as equation number 1. Okay, so in equation 1 we have given 5x minus 8y plus 1 is equal to 0, and after multiplying equation 2 by 5 by 3, we also get the equation 5x minus 8y plus 1 equal to 0. Okay, and here you say the equation 1 and equation 2 are basically the same equation. Okay, so hence the lines represented by the equations 1 and 2 are coincident. That means the lines represented by the equation 1 and 2 are actually dependent lines. Okay, so therefore equation 1 and 2 have infinitely many solutions, since we know if we have lines that represented the lines are coincident, then the pair of linear equations have infinitely many solutions. Okay, so here equation 1 and equation 2 are actually presented coincident lines. That is why equation 1 and equation 2 have infinitely many solutions. Now plot few points on the graph and verify it yourself. So here basically we have to draw the graph of this pair of linear equations. Okay, and we basically have to plot few points on the graph. Okay, so here you can do, you have given this pair of linear equations 5x minus 8y plus 1, this is equal to 0, and naming this equation 1. And other equations after multiplying by 5 by 3 we get it is also 5x minus 8y plus 1 is equal to 0. Okay, naming this equation 2. And now if we write one variable in terms of other variables, so here if we write the y variables in terms of x variables, then we'll get this equation. Then we'll get y, this is equal to 5x plus 1 by 8. Okay, and naming this equation number 3. Now we take some values of x, then we'll get some values of some corresponding values of y. Okay, so if we take x is 0, then we'll get corresponding value of y. This is equal to 1 by 8. Okay, and if we take y is 0, if we take y is 0, then we'll get the corresponding value of x. This is x is equal to minus 1 by 5. Okay, so here we basically get 0 comma 1 by 8 this coordinates, and minus 1 by 5 comma 0 this coordinates. Now we can plot these points on a graph paper. Okay, so if we have a Cartesian plane like this is y-axis, this is x-axis. Okay, so this is x-axis, this is y-axis. So you have already studied about Cartesian plane on coordinate geometry in class 9. Okay, so you have already known about Cartesian plane. So now if we take Cartesian plane, which actually consists two axes and coordinates. Okay, so here we get we get these 2 points 0 comma 1 by 8 and minus 1 by 5 comma 0. Okay, so 0 comma 1 by 8. This point basically will lie on y-axis. Okay, so suppose here we take the point 0 comma 1 by 8 point. Okay, and the point minus 1 by 5 comma 0, this point basically will lie on the x-axis, that is negative directions of x-axis. Okay, so here suppose we have this point is basically 0 minus 1 by 5 comma 0 point. Okay, and now if we connect these 2 points, so naming this point A and this point B, and now if we connect these 2 points, okay, then you will get this type of lines. So if we connect, then you will get this line. So this line basically represent the equation 5x minus 8y plus 1, this is equal to 0. Okay, and similarly you can draw the graph of this line 5x minus 8y plus 1 is equal to 0. They are basically same lines. Okay, so here this lines is also coincide with this line. Okay, so the given pair of lines are coincident lines. So the solutions of this pair of linear equations basically follow the points which lie on this line. Okay, so the pair of linear equations, the given pair of linear equations will have infinitely many solutions. Okay, now let us move to example number 3. So in this example we have given Champa went to a sale to purchase some pants and skirts, and when her friends asked her how many of each she had bought, and she answered the number of skirts is 2 less than twice the number of pants purchased. Okay, and also the number of skirts is 4 less than 4 times the number of pants purchased. So help her friends to find how many pants and skirts Champa bought. Okay, so in words, Champa given some information, and using these informations, we have to basically make a pair of linear equations. Okay, and then by graphically we can solve that pair of linear equations, and we'll get how many pants and skirts Champa bought. Okay, so let us solve this problem. So here let us denote the number of pants by X, okay, and the number of skirts by Y. Then the equation form basically by using the given informations by Champa. Okay, so you will get this linear equations. Y is 2x minus 2, since the number of skirts is 2 less than or twice of pants, twice of pants. Okay, so we get this linear equations. Y is equal to 2x minus 2, and the number of skirts is 4 less than of 4 times of number of pants. Okay, so we get another equation is y is equal to 4x minus 4. So here basically you get two linear equations. Y is equal to 2x minus 2 and y is equal to 4x minus 4. Okay, so now let us draw the graphs of equation 1 and 2 by finding two solutions for each of the equations. So when x is 2, then from this equation y is equal to 2x minus 2, we'll get the corresponding value of y is 2. Okay, and when x is 0, then we'll get the value of y is minus 2. Okay, and here you get 2 points. One is 2 comma 2 and other is 0 comma minus 2. So now we can plot these points on a graph paper. Okay, then we will get a line, and in equation number 2 we have y is equal to 4x minus 4. Okay, and if we take the value x is 0, then we'll get the value of y is minus 4, and when x is 1, then we'll get the value of y is 0. Okay, so from this from here we get 2 points, 0 comma minus 4 and 1 comma 0. Okay, so if we now plot these 2 points on a graph paper, then we'll get a line. So here let us see what will be the graph of this pair of linear equations. So if we draw the graph of y is equal to 2x minus 2, then we will get this line. Okay, so this line represented the graph of y is equal to 2x minus 2, and this line represented the graph of y is equal to 4x minus 4. And here you see at the point 1 comma 0, they are intersecting to each other. Okay, so here the intersection point of these lines actually is 1 comma 0. Okay, so now the two lines intersect at the point 1 comma 0. So here x is equal to 1 and y is equal to 0. So x equal to 1 and y equal to 0 is the required solution of a pair of linear equations. Okay, and that is actually the number of pants she purchased is 1 and she did not buy any skirt. Okay, so now you can verify the answer by checking whether it satisfies the conditions of the given problem. Okay, so in given problem we have this pair of linear equations. Y is equal to 2x minus 2 and y is equal to 4x minus 4. Okay, so given these two linear equations. So now you can check by substituting the value of x is equal to 1 and y equal to 0. Okay, so if we substitute the value of x equal to 1 and y equal to 0, then you can easily verify that this equation number 1 and equation number 2 both are satisfied by x equal to 1 and y equal to 0. Okay, so the required solution of a pair of linear equations is x equal to 1 and y equal to 0. Okay, so now let us solve some problem. So in this problem, here we have given this pair of linear equations. Okay, so the pair of linear equations, 2x, this is equal to 5y plus 6, and 15y, this is equal to 6x minus 18. And here we have to check the pair of linear equations represents two lines which are option A intersecting, in option B parallel, in option C coincident, and in option D either intersecting or parallel. Okay, so student, here we can check the pair of line, whether the pair of lines represents which are intersecting, parallel, coincident, or either intersecting or parallel. Okay, so here we can first rearrange this pair of linear equation. Okay, so if we rearrange this pair of linear equation, then you can get 2x minus 5y minus 6, this is equal to 0. Okay, and 6x minus 15y minus 18, this is equal to 0. So now if we compare this pair of linear equation, okay, with the general form of a pair of linear equations. So we know the general form of a pair of linear equations, that is a1x plus b1y plus c1, this is equal to 0, and a2x plus b2y plus c2 is equal to 0. Okay, if we compare these equations with these equations, then here you will get a1, this is equal to 2, b1, this is equal to minus 5, and c1, this is equal to minus 6, and a2, this is equal to 6, b2, this is equal to minus 15, and c2, this is equal to minus 18. And now find the ratios. Okay, so here you can find the ratios. So a1 by a2, here we can find the ratios. a1 by a2, this is equal to 2 by 6, and b1 by b2, this is equal to minus 5 by minus 15, and c1 by c2, this is equal to minus 6 by minus 18. Okay, and this is equal to 1 by 3, and this is equal to 1 by 3, and this is equal to 1 by 3 also. Okay, so here you can see the ratios a1 by a2, b1 by b2, and c1 by c2 are all equal. Okay, so here a1 by a2 is equal to b1 by b2 is equal to c1 by c2, and we know the pair of linear equations are coincide to each other when the ratios a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay, so here a1 by a2, these all ratios are equal. So the pair of linear equations 2x is equal to 5y plus 6 and 15y is equal to 6x minus 18 represents two lines which are coincident. Okay, so here for this question, option number C is correct answer. Okay, so now let us move to question number 2. So in question number 2, we have this pair of linear equation 3x plus 2y is equal to 7 and 4x plus 8y minus 11 is equal to 0. Okay, and here we have to check the pair of linear equations are, in option A we have given perpendicular or parallel or intersecting or coincident. So among these four options, which option will correct, that we'll have to check. Okay, so we can check by comparing this equation with the general form of linear pair of linear equation. Okay, and then find the ratios a1 by a2, b1 by b2, and c1 by c2. Okay, and we know some conditions. So if we use that conditions, then we'll get the geometrical interpretations of this pair of linear equations. Okay, so student, here we can first can be rearrange these equations as 3x plus 2y minus 7 is equal to 0 and 4x plus 8y minus 11 is equal to 0. Okay, so now if we compare this equation with the general form of pair of linear equations, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So here a1 is equal to 3, b1 is equal to 2, and c1 is equal to minus 7, and a2 this is equal to 4, b2 this is equal to 8, and c2 is equal to minus 11. Okay, now the ratios a1 by a2 this is equal to 3 by 4, and the b1 by b2 this is equal to 2 by 8. Okay, so here you can see a1 by a2 this does not equal to b1 by b2. Okay, and we know the lines are intersecting at exactly one point when the ratio a1 by a2 does not equal to b1 by b2. Okay, so the pair of lines represented by the linear equations 3x plus 2y this is equal to 7 and 4x plus 8y minus 11 this is equal to 0 are intersecting. Okay, so for this question here option C is correct answer. Okay, now let us solve question number 3. So in question number 3 here we have given the pair of linear equations y is equal to 2 and y is equal to minus 3. Okay, so in this equation the x variable is not involved. Okay, so we can represent, we can find the solutions by using graphical method. Okay, by using graphical method. So here we basically have to draw the lines y is equal to 2 and y is equal to minus 3. Okay, so student, you have Cartesian plane like this. Suppose you have Cartesian plane is y axis, okay, and this is x axis. You have this Cartesian plane. So now if we draw the line y is equal to 2, so here basically y is some constant, and we know when y is some constant then that line basically is a line which parallel to x axis. Okay, with distance 2 units at the positive directions of y axis. So here this is 1 unit, this is 2 unit, this is 3 unit, and this is 4 units, and in negative side we have minus 1 unit here, minus 2 unit, minus 3 unit, minus 4, and so on. Okay, so the graph of y is 2 is basically this line. Y is equal to 2, this represents this line, is y is equal to 2 line. Okay, and y is equal to minus 3. This represented by this line. So this is y is equal to minus 3 line. So here you can see this line represented the equation y is equal to 2, and this line represented the equation y is equal to minus 3. Okay, and here you can see these two lines are parallel to each other. Okay, so these two lines are parallel to each other, and we know if we have a pair of linear equations, they are parallel to each other, then they never intersect or they never coincide to each other. Okay, so the pair of linear equations has no solution. Okay, so has no solution. So here in option D we have no solution. Okay, so for this question the correct answer is option number D. Now let us move to question number 4. So in question number 4 we have pair of linear equations x is equal to 5 and y is equal to 5. Okay, so here basically we will use graphical method of solution of a pair of linear equations. Okay, so we can draw the graph of the equations x equal to 5 and y is equal to 5. Okay, so if we have this Cartesian plane, you have this Cartesian plane. This is x-axis. Okay, this is x-axis, this is y-axis, and this point 1, 2, this 3, this is 4, this is 5, and here 1, this is 2, this is 3, this is 4, and this is 5. So y x equal to 5, this is basically a line which is parallel to y-axis with from the distance 5 units at the positive directions of x-axis. Okay, so this line basically represented this line represented the equation x equal to 5. Okay, and the line y and the equation y equal to 5 represented by the equation by the line this line is basically y equal to 5. Okay, so this line represented the equation y equal to 5, and here you can observe that at this point they are intersecting. Okay, so here this point is basically the coordinates. The coordinates of this point are 5, 5. Okay, so the coordinates of the intersecting point are 5, 5. So the pair of equations x equal to 5 and y equal to 5 has unique solutions since they are intersecting at exactly one point and the coordinates of that point are 5, 5. Okay, so here option B is correct answer. Okay, now let us move to question number 5. So in question number 5, here we have given this pair of linear equation 3x by 2 plus 5y by 2, this is equal to 7, and 9x plus 10y, this is equal to 14. Okay, so here we have to check this pair of whether the pair of linear equations are consistent, inconsistent, consistent with one solutions, consistent with many solutions. Okay, so you can check by comparing this equation with the general form of pair of linear equations. Okay, and then find the ratios a1 by a2, b1 by b2, and c1 by c2. Okay, then you can easily say. So this problem is your homework problem. Now I stop here this lecture. Thank you very much to all of you.